For days now, the atmosphere has been pulling in two directions. In the west, milder air trying to advance. In the east, colder air refusing to give way. Hey everybody, welcome to the weather breakdown. Today is January 14th, and everybody who has been looking at the models lately probably noticed the same thing. This ongoing tug of war between the colder air mass over Europe and the warmer air mass over the Atlantic. Some models and some runs predict that the warmer air mass over the Atlantic gets pushed far east. Other models and runs predict that the colder air mass over Europe gets as pushed far as the UK. There has been no agreement whatsoever. So today we're going to look at what the situation is currently and how it will evolve. Let's dive straight in. So if you look at our observations here, we can see a low pressure center here with its frontal boundary extending like that. There's also a trough here with an upper level flow regime moving in that direction. There's a trough here just south of the Iberian Peninsula as well, with a closed low circulation here leading to some convection here where the convergence along the coast is strong enough to push the air upward. There's also a rather deep trough here moving in that direction with a closed low circulated there. And there's also a rather intense thunderstorm happening currently over the Atlantic as well. Let's delve a little bit into that one because there's some cool things that we can see there. So when we look at the storm here, we can see a number of things. We can see, number one, that it has a back-sheared anvil, leading to think that this thunderstorm won't die anytime soon. As you can also see, there's a sort of flanking line active with the storm as well. We can also see that the low-level inflow is moving towards the northwest, while the upper-level flow at 6 kilometers is moving towards the northeast, meaning that there's a 90-degree wind shear between 0 and 6 kilometers high above the surface. What we can also see in this thunderstorm is if we turn on the water vapor imagery, if you look here along the flank or along southwest flank rather of the storm, you can see this band of lower brightness temperatures. This signifies that the updraft is strong enough to push the air around it down, and when the air sinks around the storm, it tends to dry due to adiabatic compression, leading to darker brightness temperatures in the water vapor imagery as well. So it's quite a hefty storm there. Luckily, I'm not in a boat right now. All jokes aside, let's dive straight into the weather models now and see what we can see of this ongoing war over Europe. So if we look at our weather charts here, we can see all these lows with their precipitation regimes trying to impact the European mainland. But as we said, there's an ongoing war going on between where the boundary of the cold air actually is. And today I'd like to look at the drivers behind that system, because as these lows try to bash the European mainland, if we go forward in time here, you can see there's a massive wind field here. There's a massive upper level wind field here. And if you move forward in time, you can see here a massive pronounced upper level trough here. This has a massively high amplitude. But you can also see here, there's a closed upper level low here with its maximum wind field in that direction. So if we have an upper level trough here with a maximum wind towards that, and you have a maximum wind towards that, put a pinwheel in here, this starts to rotate in that direction, meaning there's going to be a anticyclonical circulation here, as you can already see here by the 500 millibar height lines here, creating a anticyclonical circulation leading to a high pressure area there. So if we go forward in time, you can see that going on here. You can see that high pressure area, okay? In the meantime, as this trough here with this maximum wind field digs further south, you can see that it starts to be cut off a little bit. And this creates a regime, or an engine rather, where if you go forward in time, you can see that happening here. You can see this low pressure center here with its trough moving more or less in that direction. You can see this anticyclonical circulation moving in that direction. So this is funneling eastern air towards the west. And this is why there's a constant struggle here with this Atlantic air trying to bash inward and the European continental air preventing from reaching the European mainland. At least in the American model, it's that way. And if we go forward in time, look at how this anticyclonical circulation behaves. because it holds the key why this air isn't able to reach Western and Eastern Europe even. If you go forward in time, you can see here along this high pressure area, there's a number of inverted troughs that are forming. You can see one here. This is an inverted trough with its maximum wind here to the north. Look at how this trough evolves. If you go forward in time, look at what's happening with this trough. It gets deflected around the anticyclonical circulation while it is a trough with its upper level flow regime moving in that direction, right? And watch what happens if this one bumps into this boundary here between the juicier Atlantic air and the air mass over Europe. Let's see what happens, right? If we move forward in time here, you can see at this time frame here, around the 22nd of January, how this inverted trough bumps or holds back this flow, as we have seen, tries to move here towards the west. Okay, let's see that happening in action here. I'll rock it actually back and forth so you can see. We see the inverted trough here with the IPV anomaly attached to it, so it's definitely a trough. Look at how it shears off the flow as it tries to invade from the west. You see that deformation zone of the two regimes colliding here, where it shunts a portion off towards the north and it deflects portion towards the south. If you go forward in time, you can see that happening. See, it deflects everything towards the south here, along this region here. It deflects it towards the south. Now, if we go even forward in time, there's another one here with an IPV anomaly here with the maximum wind field going to reinforce this inverted trough regime. Watch what happens with that one. If you go forward in time, you can see that inverted trough here with this maximum wind field to its north, increasing vorticity, lowering pressure, leading to precipitation here, which falls as snow because the air is cold enough to allow for frozen precipitation type. If you go forward in time, you can see all that whole inverted trough move further and further and further towards that direction, again bumping against this juicier air mass that is trying to invade from the west. You can see the same thing happening there as well. If you go forward in time here, you can see that right here. In this location, you can see that deformation zone again here. It bumps against that flow regime coming from the west, again preventing it from ever reaching the European mainland. If you go forward in time, you can see that happening again, and you can see again that this sets up a split flow regime with air moving like this and with air moving like that. Again, deflecting all this motion to the west towards the north and the south. And as the GFS goes forward in time, you can see that as this flow gets redirected towards the south and the southeast, that the orientation of this low starts to become northwest to southeast, bringing juicier and juicier and juicier Mediterranean air over southern part of Europe, leading to precipitation, leading to snow, leading to thunderstorms even. It can be an interesting time. Now, when we look at the European model, we can see more or less the same. In the beginning, we have all these low pressure centers here as they try to invade the European mainland. If you go forward in time, you can see more or less the same thing. There's also a high amplitude trough forming here. You can also see this upper level low here with a circulation like that. And if you can see here by the spacing of the 500 millibar height lines, there's a wind maximum there too, leading to this anticyclonical circulation, leading to this high pressure area here that is going to invade here from the northeast. So if you go forward in time, take an eye on this low pressure, on this high pressure area here. As you can see, it does exactly what we have predicted. Also, if we look here, you can see by the spacing of the 500 millibar height lines as well here that there's a jet maximum here towards the south. So this doesn't change a lot from the American model. There's also a jet maximum here dragging this whole trough, this whole massively high amplitude trough downward, southward rather. right? If you go forward in time, you can see that happening, which creates a low radar here. If you go forward in time now, let's see what happens with that low. It moves towards the southeast, but there's already another impulse here with the jet maximum moving towards that direction. There's still this high amplitude trough here, which led to this reinvigoration of this high pressure area and this very large anticyclonical circulation, still driven by cyclonical circulation moving in that direction. So we have this here and this here, making this one go anticyclonical here. And we have this low here, which moved towards the southeast, creating this engine here of air being deflected like here and air being deflected like here. So we have already air being funneled towards the west as well. If we go forward in time here, let's see what happens. We see again here more impulses going towards the southeast. There's also still the invigoration here of this high amplitude trough here, which is now a high amplitude ridge, which makes it so that this whole zone here is dominated by high pressure. And this prevents, obviously, from all these lows bashing in the European mainland. So it's more of a classical situation where it's not the inverted troughs that's being flung around the southern flank of the high pressure areas. It's just a high pressure area. It becomes that big that it just prevents this milder air from reaching the European mainland. If you go forward in time, we will see what transpires. If you go forward in time here, you can see all these impulses here moving more towards the southeast, reinvigorating this whole engine here, this whole low pressure center here, which will have massive implications on our high pressure centers later in the loop. If you go forward here, you can see that all these lows here, as these new impulses join these already present low pressure centers here, that they just become elongated towards a zonal direction, reorienting this whole anticyclonical and cyclonical circulation here, reorienting the flow as it moves from the east. You can see that happening. If you go later in time, right, you can see here now that these lows here, they are now already here, right? With a circulation like that, while here all these troughs are moving in that direction. So we have a outside the domain here, we have a ridge. This flow actually comes back around here, and you can see if this one here keeps growing, that this one will start to migrate towards the south here as well. And check what happens when it phases with this engine here. If you go forward in time, right, you can see it phasing here with all these lows here, reinvigorating these already existing low pressure centers here. And this sets up a very good motor here, or an engine rather, with a cyclonical circulation moving in that direction, anticyclonical circulation moving in that direction. In between, you have this cold air being funneled towards the west. If you go and we look at the same principle, but from an air mass perspective, you can see that happening. Our low pressure center here moving towards that direction. Check the high amplitude trough that is going to form. We have the cyclonical circulation here. In between, there's a high pressure area reinvigorated there. So we can see the same thing, but from a different perspective. We can see these flows here as they try to merge here with these low pressure centers here, setting up the engine to eventually drive the eastern colder air towards the west. If we go forward here, you can see that it digs further southward here. And as this trough here tries to join with the existing cyclonical circulation, look at the vectors here. This is cyclonical circulation. It sets up this engine where all this cold air, check these vectors here, is being funneled towards the west, essentially blocking the warmer air from invading the European mainland. Now, the difference between the GFS and the European model is that the European model predicts a classical situation where high pressure area just builds and builds and builds and expands, setting up a regime with a low pressure center in the south and a high pressure area in the north, funneling that cold air towards the west, essentially blocking the western circulation from ever reaching the European mainland. The GFS is doing it more intricately with a high pressure area in the northwest, and there are these inverted troughs being flung around the high pressure area, essentially splitting the air as it moves towards the east from the Atlantic into a northern and a southern branch. And it does this repeatedly. And this is also the reason why the European model, we have seen this gradual shift towards a high pressure area, and the GFS was actually being very jumpy. The problem with these small lows, as they are being flung around a high pressure center, they are very difficult to resolve correctly and very difficult to miss. And this is why the GFS output was constantly jumpy this whole time. You did see some fluctuations, but not as extreme with the European model. We'll have to see the coming days what the next situation brings, where it will be cold, where it will be warm. In a couple of days, we will have more clarity on that as the situation evolves. Let's see you in the next video, guys. Bye, everybody.